Good morning. I guess we're live here. Wow, only 3 of you. A little bit shocking. Did you have any questions on lesson 3.2? Got to live in the joy of the shortcut this time. Any questions? Oh, 99? Ah, okay, we do have some questions. I see them there popping up. All right, number 99. So let's find, so we're back to 3.2. Number 99. All right, let me copy that. Welcome, Maria. Okay, number 99. So here we go. In exercises, use this position function, S of t equals negative 16t squared plus v0t, that's the initial velocity, times the time, plus s0, the initial height. Okay, so let me write, the silver dollar is dropped from the top of a building that is 1,362 feet tall. So let me write out the function with that in there. So we have S T equals negative 16 t squared let's see, and did they tell you in the book? Okay, just checking. All right, negative 16 squared plus v0 sub t plus the initial height of 1362. Okay, so so the reason I put this in there is because that's the height it was dropped from. Okay, and the initial velocity, we don't have that, but all right. So we then want to find the average velocity. Okay, the average velocity has nothing to do with calculus. The two intervals are from 1 to 2. So at 1, what would be the height? Well, if you plug in 1, negative 16, yeah, they didn't give us the initial velocity. I'm just trying to see in the book if they gave you any information on that. So let me go back, see if they have an example here. Yeah, the initial velocity is 16 feet per second. Okay, so from this problem right here, that's the V0. All right, so let me just come back. We'll redo this. Let's put the 16 in here. Okay, so now we can figure out 1. So if you square 1, you get 1. So you get negative 16. Negative 16 plus 16 is 0. And then you get 1362. And the other point is 2. Okay, what do we get? 2 squared, 4. And 4 times 16 is negative 64. Plus 64. Oh, wait a second. Sorry, plus 32 is negative 32, so it's dropped 32 feet, so it's at 1330. Okay, so now, how do you find the average velocity? By doing, basically, it's the average rate of change. So now you take your 2 points and you do a slope. y2 minus y1 over x2 x2 is 2 minus x1. So what we get here is 32 over 2. So there's the average velocity. And that is, did they say what it is? Yeah, I don't know if that's feet or whatever. But anyway, that's your answer for part A. Okay. So now let's go to part B. Whoops. Let's go to part B. Keep that high enough that I can see it. Oh, A. All right. I've got this a little mixed up. We just did B. Sorry. So we found the average velocity over the interval from 1 to 2. Part A was, what are the position and the velocity functions? Well, the position function is what I have up at top there. ST negative 16t squared plus 16t plus 1362. Now, the velocity is S prime of t. In other words, it's the first derivative. First derivative, negative 32t plus 16. That's a constant, so that's it. So there's part A. The position, and so this is position, and this one is velocity. Okay, part C. This is going to be pretty easy now, because now all we have to do is find, we already have the derivative right there. So for part C, what's the velocity at 1? At 1, negative 32 times 1 is negative 32, negative 32 plus. So negative 16 is the velocity at second 1, and S prime at 2 is negative 64 plus 16 is what? Negative 64 plus 16 is negative 48, I believe. Okay, so that's part C. And then part E says, find the velocity of the coin at impact. Okay, so let me get that one going here. All right, at impact, well, when does impact occur? So that's the first thing we got to figure out. So we go back to this equation. Just copying the top equation again. And at impact, that will be equal to 0, because the height, that's what impact means. The height will be 0. So let me raise that up a little bit more. All right. So when will that be? So 0 equals negative 16 t squared plus 16t plus 1362. Well, let's make it easy on ourselves. Let's solve by using the quadratic formula. So x, or in this case t, t is equal to minus b plus or minus the square root of b squared minus 4 times a times c all over 2a, which 2a is negative 32. Okay, I guess this is quite the problem, huh? Takes a while. Negative 32. Okay, well, anyway, you could solve that and you'd find out what time. And then, I don't know if I want to go through and solve the quadratic, but you would get two answers. And the one you want is the one that's positive, because time cannot be negative, except at NASA. Just joking. You know, t minus 10 seconds. Time can never be negative. So once you know when it happened, then all you got to do to finish it up is find out s prime at, and then plug in, you know, whatever this time is up here, plug that in there. And you would find out how fast it was going. I'm going to leave this calculation so that we can make a little, I mean, we've already used a couple 12 minutes on this. So, okay. So that's basically, except that I did it out of order, that's number 99. All right, Weston, 89. Let's go take a look at 89. I'm going to move over here. 89. All right, 89. Grab. And I better grab this whole thing because then we can see the directions. Copy. Okay, come back. Okay, number 89. So the directions in exercises 87 to 92, determine whether the statement is true or false. If it's false, explain why or give an example that shows it's false. All right, 89. If y equals pi squared, then its derivative, dy dx is another way to write it, then the derivative is 2 pi. And the answer is false. And the reason it's false is pi squared is a constant, right? Isn't pi a constant? Well, then pi squared is a constant. And what's the derivative of a constant? 0. So that's why that one should be false. 57. Let's take a look at 57 next. Number 57. Determine the points at which any of the graph has a horizontal tangent line. All right, let me grab again this problem. With the directions. Copy. Okay, so get this in a little better position. All right, so determine the points, if any, at which the graph of the function has a horizontal tangent line. Well, the way to find a tangent line is to find the derivative. So if that's your f of x in 57, then what's the derivative? Okay, well, we can use the shortcuts, right? We can say f prime is 4x cubed minus 4x. Okay? Right? Because then the constant, it's 0, so we don't have to write it out. A horizontal tangent line would have what kind of a slope? A 0. So here's our derivative. The question is, when will that equal 0? So let's set it equal to 0 and find out. So we set it equal to 0. We can, what, take a 4 out, and we can take an x out. And that leaves us with x squared minus 1. So now, how can that equal 0? When 4x equals 0? And that would be true when x is 0. So there's your first answer. And when x squared minus 1 would equal 0. And x squared minus 1 equals 0 when x squared equals 1. And that has two answers, plus and minus 1. So our two answers, actually three answers. There are three places where we will have a horizontal tangent line: at 0, at -1, and at +1. Now, just to show you this in action, let's just do a quick plot. X to the 4th minus 2x squared plus 3. We'll just run a Desmos real quick. And we'll show the plot. Okay, so we have x to the 4th minus 2x squared plus 3. So remember what we got for our three answers? Let's just go back here. We got 0, -1, and 1. And if you look on here, at 0, you see how there's a horizontal tangent line right at that point? It goes right across at this point. And then at 1, oh, yep, that's a horizontal tangent line, and at +1. So we just confirmed our answer is correct. So so far I received 3 requests, and we did them. Does anyone have any further questions or follow-ups to that? Claire or Weston, did you need any follow-ups to that? Okay, then let's get, no thank you. All right, let's go back to, so the beginning of our lesson, product and quotient rules today, higher order derivatives. And just so you know, I'm thinking we're going to need 2 days on this lesson anyway. So the fact that we had a little time here with questions, that's fine. I think we're going to need, we were going to need 2 days anyway. So here's what we want to do today. 4 things. You see them here as bullets underneath. Find the derivative of a function using the product rule. Secondly, find the derivative of a function using the quotient rule. I know you don't know what those 2 rules are yet. Third, finding the derivative of a trig function. Okay, we've already done some of those, but now we can do some new ones. And we may not have time for this last one today, but finding a higher order derivative of a function. All right, so first of all, let's look at the product rule. So the product rule, here it is. It states the product of when you have two functions being multiplied together in the statement there, it's f of x times g of x. Those are two separate expressions. And when they're being multiplied, sometimes you can't, when you multiply them out, you still can't find the derivative. So here's the rule. Take the first function times the derivative of the second plus the second times the derivative of the first. And this is a rule that you're going to have to memorize. So one more time. To take the derivative of the product of two functions, take the first function times the derivative of the second plus the second times the derivative of the first. Well, let's apply it right away. So here's our example. All right. So notice I have two things here that need to be, by the way, this one we could have cheated on, and we could actually multiply it out and then use the rules that we learned from last class. But just to learn the product rule, we're going to go ahead and do it using the product rule. By the way, there are other things that you can't just multiply out and use yesterday's rules. So it becomes absolutely necessary that you learn how to use the product rule. All right, so here we go. We take the first function times the derivative of the second. By the way, d over dx, that's a way of saying derivative. So 3 minus 2x squared times the derivative of the second plus the second times the derivative of the first. So you see how we applied the rule. Okay, so the first 3 minus 2x squared, the derivative of 5 plus 4x, yesterday's rules is 4, right? Because the constant, 0, that's not there. The derivative of 4x to the first, using the quotient rule, or the constant rule, it's not the constant, but the coefficient rule, it just becomes 4. Plus the second times the derivative of this thing over here. This thing. And what's the derivative of that thing? Well, the derivative of 3x is 3, and the derivative of negative 2x squared is negative 4x. Okay, so now at this point we've applied the quotient, the product rule. And now it's just a matter of do the algebra 1 and multiply it out. 4 times 3x is 12x. 4 times negative 2x squared is negative 8x squared. And then you got to do this FOIL here. 5 times 15. 5 times 3 is 15. 5 times negative 4x is negative 20x. And 4x plus x plus 3 is 8x. And then negative 20x plus a positive 8x. I'm sorry, a negative 20x plus a positive 12x comes out to a negative 8x. So they've already simplified that. And 4x times 4x, negative 4x, negative 16x squared. Now you're just adding, so add like terms. Derivative is complete. So, like I said, we could have cheated on this one. Here, let me just show you what I mean by that. We could have multiplied this out. 3x times 5, 15x. 3x times 4x. Negative 2x squared times 5, negative 10x squared. Negative 2x squared times 4x. Negative 8x cubed. So let me see, did we do that right? 3x times 5, 15x, 3x times 4x, 12x squared, negative 2x squared times 5, negative 10x squared, and negative, yeah, okay. So there it is. Now, what's the derivative? Well, you get 15, right, using the rule. You get 24x. Minus 20x, and then you get negative 24x squared. And when you write that out and simplify, bring together the like terms, you see how we got the same answers. So on that one, we had a choice. But on the next one we're going to do, you're going to see that sometimes you don't have a choice. You have to use the product rule. So let's go to, so here's an example. You have to use the product rule to do this one. Example 2. Y equals x times e to the x. So the two things that are being multiplied here are x and e to the x. They are being multiplied, therefore we can use the product rule. So we take the first times the derivative of the second plus the second times the derivative of the first, just using the words of the product rule. All right, the first, x, what's the derivative of e to the x? Well, that's that beautiful one from yesterday. It's just e to the x plus e to the x. And what's the derivative of x? 1. So you could just leave this like this, x e to the x plus e to the x. That would be correct. And then if you factor out an e to the x, you can also write it this way. So that derivative would be impossible without the product rule. So this is the main this is the real reason I'm teaching that we're teaching this to you. You have to have it. Let's do another one. Let's take a look at example 3 down there. So we have this function 2x cosine x minus 2 sine x. So now this is a little, okay, so here in this part right here, that's where we have a product, right? We have this times that. This part, well, that we could have done yesterday. And that's this part over here, the constant multiple rule. So this part over here is the new part. So we got to use this rule. The first times the derivative of the second plus the second times the derivative of the first. And then this part, you know the constant rule. You can pull the constant out, take the derivative of the thing. Okay. So now, going a little further, what's the derivative of the cosine? Minus the sine, all right? What's the derivative of 2x? 2. So that's that product rule. And then over here, what's the derivative of the sine? The cosine. Now do you see where they got the answer? Because do you see that these two things wipe each other out? That's this number 1 is cosine is 2 cosine x, and number 2 is negative 2 cosine x, and that equals nothing. What's left? The part in the beginning. So you notice how the sign was just moved out in the front. A positive times a negative is a negative. Any questions? Okay, well, we're going to move on to the quotient rule. So I'm basically just teaching you 2 new rules today, and they're huge. This time, what happens when you have a function divided by another? Now, we learned yesterday that sometimes you could break it up by going backwards from a common denominator and just making each fraction be over that. Yeah, that's awesome. You can't always do that, and you need the quotient rule. So here it is, and sorry this doesn't get any shorter than this, but when you have f of x function divided by the g of x, the derivative is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. they've got the words up here. You know, you can get them from right. So I'll just go through that again. When you have a quotient and you want to take the derivative, you have to take the denominator multiplied by the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Again, you need to commit that to memory. Okay, now let's make use of it. So let's do this problem right here. And you can't do this problem using any of the rules from yesterday. So without the quotient rule, well, we wouldn't be able to do it. All right, so here we go. Denominator, x squared plus 1, times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So all we did was just kind of, use the rule. And then now let's carry it out. The x squared plus 1 times what's the derivative of 5x minus 2? Shortcut from yesterday, 5. Minus 5x minus 2 times what's the derivative of x squared plus 1? Power rule, 2x plus nothing, 2x. Denominator, by the way, don't ever square that denominator. Just leave it as x squared plus 1 quantity squared. You don't need to multiply that out. All right. But we can simplify the top, and we have to. So what is 5 times the quantity x squared plus 1? 5x squared plus 5. What happens when you multiply this out? Well, you get negative 10x minus 4x. I'm sorry, negative 10x squared minus 4x, and that's all being subtracted. So then you got to subtract this, and what? You're going to wind up adding there because minus a negative. Anyway, you bring the like terms together and you leave it in that form. We're done. Derivative using the quotient rule. All right. Let's talk about this now. So this is just algebra advice. This is not a derivative. I mean, well, this is pre-derivative. So when you get an expression like the one at the top here, 3 minus 1 over x plus 5, that 3 minus 1 over x is not in a very usable form. Now, what I've been doing in class is writing it like, we've been writing it like this. And then we would have gone ahead and probably gotten a common denominator. So we'd have multiplied this by x over x. And we'd have gone that way. Well, another way to do it is multiply the top and the bottom by x. So you notice what they did? They multiplied the top by x right here and the bottom by x. That's legal because you multiply the top and bottom of a fraction by the same thing. That's not changing it. So what happens then? On top, you get 3x minus 1. Oh, cool. We lost the fraction. And on the bottom, you get x squared plus 5x. Now we're ready to use the quotient rule. So all this really was advice on how to kind of get the problem in shape to begin. So now that you've got it in shape, now use the quotient rule. Denominator times derivative of numerator, 3 minus numerator, 3x minus 1 times derivative of denominator, Oh, hang on. I lost everything, so let's see what's going on here. Okay, we're back. So we just did, yeah, so here's the derivative of the denominator, 2x plus 5, and then just have it over the denominator squared. And again, don't multiply that thing out on the bottom. Then just do, all right, so now we're home free. Just simplify, take the x squared plus 5x times 3, multiply these two using FOIL, apply the minus sign, simplify the numerator. There's your derivative. Now, so I guess let me just pause there. Did you follow on how I found the derivative? You know, you guys can speak if you want. It's not, it's you're going to be fine. If you want to speak up or ask a question, it really helps everybody. So anyway, so I got the derivative right down here. That's this thing right here. There's your derivative. Now, the final part of the problem was, can you find the equation of the tangent line at this point up here at the top, negative 1, 1? So this is, so what you've got here is, this is f prime. This is f. Sorry, I'm not getting the pen to work, but this right here is f prime at x. Sorry for that being so sloppy. So now you need to find what's f prime at that guy right up there, that x coordinate at negative 1. So you just plug in a negative 1. And what happens on the top? Negative 1 squared is 1. Negative 3 times 1 is negative 3. 3 minus 2 is negative 3. Negative 3 minus 2 is negative 5. And negative 5 plus 5 is 0. And on the bottom, what do you get? Negative 1 squared is 1. 1 minus 5 is negative 4. Negative 4 is 16. So you get 0 over negative 16, which is 0. Oh, so now, if I get my pen to work, all because we lost power or something here. Come on, sweetheart. There we go. Okay, so now that you know the slope is 0, you just found out the slope of the tangent line. So now, they say, by the way, use the point slope form. I would use the slope intercept form. So you know that the equation looks like this. We now know m is 0. And now substitute in your point. 1 for y from right here. 1 from y. And 0 times negative 1 for x. And you can see that b is 1. So therefore, y equals 0x plus 1. And that is the final answer to this problem. Find the equation of the tangent line to this graph at that point, way up at the top. Okay. Well, that was with relatively great difficulty. All right, we're going to do a trig function now. Or at least we'll get started. All right. So differentiate both forms of y equals 1 minus cosine over sine equals cosecant minus cotangent. All right. So how does one take the derivative of a quotient? And here's our quotient. You answer, use the quotient rule. So you would take the denominator times the derivative of the numerator. What's the derivative of the numerator? Derivative of 1 is nothing. The derivative of cosine is minus the sine. So what's the derivative of minus cosine? Plus sine. Minus the numerator times the derivative of the denominator. Derivative of sine is cosine. All right. So now when you multiply this thing out, what's sine times sine? Sine squared. What happens when you do this part? After you work it all out, you get this. And now, remember this identity from trig? Sine squared plus cosine squared equals 1. So this part right here, you can replace with a 1, which they did. Voila. We have derivative. So just to show you, you need the quotient rule with certain trig identities also. All right. So now this is not calculus. But what they're going to show you in this little chart is this is algebra advice. Okay? So all they're saying is after you're done taking the derivative, let's say you get this. How should you simplify? Well, that's pretty no-brainer. You just multiply, and then add and get like terms. Okay. Yeah, so this is just it. I guess these are just simplifying rules. So they're saying bring your like terms together, finish multiplying it out, bring it all together, and make it as simple as possible. But on the bottom, if you have like a square, let that be. So that'll help you to understand the forms in the back of the book. All right, let's get started on higher order derivatives. So just a little information sheet here. So everybody, you all know how to take a first derivative. That's called taking a derivative. So, and by the way, this last column, in fact, we're not going to look at this one very much either. Let me just, there are 5 columns here, and the last 2, we're just not going to use those forms. So what's the first derivative? We call it y prime, or we can call it f prime of x, or we can call it dy dx. So we have 3 different ways of saying, all right, there's the first derivative. Now, if you take the derivative of the derivative, that's called the second derivative. And we would call that y double prime, or f double prime of x, or d2y over dx. So the derivative of x with respect to y twice. And there is even a third derivative, a fourth derivative. And when we get so many primes here that after 3 we just use this little 4 in parentheses, or 5, or n. So that's just a matter of notation. This is strictly notation. But we're going to make use of it right now and try to see an application here. So, example 10. Find the acceleration due to gravity. All right. So, you probably know this, but it talks about in 1971, David Scott did a famous experiment on the face of the moon. I can play you the video. I just don't have it handy right now. But he dropped a hammer from his one hand and he dropped a feather from the other. And the hammer and the feather hit the surface of the moon at the same time. The reason is they don't have an atmosphere on the moon. And so here on Earth, if you dropped a feather, the thing would float left and right and finally reach the ground because there is this atmosphere. But on the moon, it just goes by weight. And we find out that gravity doesn't depend on weight. The heavier object falls at the same time as the lighter object. I know that seems foreign to us because we're so used to living in an atmosphere. But anyway, kind of cool. So here is what's called the displacement function. This S of t is talking about the position. How many, what height, S of t, what height is the object after t seconds? And this is that's what height it is after t seconds. Okay, so that's just your straight function. Now, when you take that distance function and take its first derivative, you get, well, here, we do it right here. Here's the function for the position. Take the first derivative. What's the first derivative? Power rule, 2 times negative 0.81 is negative 0.162 times t plus nothing. That is, so when you have the position, when you take the derivative, you're finding the rate of change of the distance. The rate of change. And we call that speed. That's the rate of change. How fast is your rate of change when you go to school? And that would be how fast you are traveling. That's called the speed or velocity. And if you take the derivative of that, that's called the second derivative, s double prime of t. What's the derivative of that? Negative 1.62 t, you just get negative 1.62. That is the acceleration. So what's the rate of change of the speed? So in other words, how fast are you changing speed? If you're in a car and you hit the brake, you are rapidly decreasing your speed. If you're in a car and you're driving and you step on it, how fast are you changing your speed? That's called acceleration. So a really cool thing happens. When you take a position function and take the first derivative, you will have the velocity. And if you take the derivative of the velocity, you have the formula for acceleration. So that is pretty cool, and it's almost a given that you're gonna see in the assignment, you're gonna get some like this where you're given the position function. Yeah, I still have 2 minutes left, Claire. She asked if we have an assignment since we didn't finish. No. Well, yes, but it's not due tomorrow. Yeah, you're right. It's only 1 minute to go. Thank you, Claire, for getting me on task here. So I'm going to show you the assignment, and I'm going to encourage you to get started on it. But, Claire, you're right. We need a little more time with this. So here is the assignment for 3.3. And I will see you tomorrow when we will, we're going to continue. I just have a little bit more to do, and then we need to practice some more. Does anybody else have a question or a comment? All right, then. I will see you. I guess that I will see you tomorrow.